In example 11, we're told that every 10 years the U.S. government takes a census or a survey of the population. One possible result of changes in population is that the number of U.S. representatives for a state may change. Find the approximate percent decrease in the number of representatives for Michigan. Round your answer to the nearest tenth of a percent. So we see in year 2000 they had 15 representatives. In the year 2010 they had 14 representatives, so their total population as a state must have gone down. So we're going to use our equation, change equals percent times the original. Percent times the original. And we need to calculate what the number of representative change was. So we had 15, we're now down to 14. 15 minus 14 is a change of 1. They had a change of 1 representative, so I'll record that in the change spot. And I'm trying to figure out what the percent decrease is, so I'm going to use R for the percent, times the original number. Well, again, the original is the one that happens first. 2000, that year came first. They had 15 representatives in, so that's going to become our original value. To get the value of R, well, we're going to have to divide both sides by 15. Here on the right, 15 divided by 15 is 1, leaving us with R. 1 divided by 15, if you punch that into your calculator, you get 0 and 0, 6, with the 6 repeating. Okay, but that's our rate in decimal form. We now need to convert that into a percentage. So that's going to become 6 and 6/10 repeated as a percentage. Okay, well, the question says round your answer to the nearest tenth of a percent. So this is going to be approximately. All right, well, remember, that's a bunch of 6's repeating. 6, 6, 6, 6, 6. So right now it looks like 6 and 6/10 repeated, but I have a 6 here in the hundredths place that's going to round us up. So this is going to be approximately 6 and 7/10%. And so we would say there was about a 6 and 7/10% decrease in the number of representatives. There was about a 6 and 7/10% decrease in the number of representatives. I'll move the camera over so we can see that. In question 12, we're asked to estimate the percent increase in the flower's growth. Round your answer to the nearest percent. And so looking at the original picture of our flower, it was 11 centimeters tall. And then after it's grown to a size of 20 centimeters. And we want to know what the percent increase was in the flower's growth. So again, we're going to start with our formula. It's change is equal to the percent times the original value. And again, I don't know what the change is, but I can calculate it. It was 11 centimeters, now it's 20 centimeters. 20 minus 11 is 9. It has grown 9 centimeters, and so that's going to be my amount of change. All right, I'm setting that equal to R, the percent, because that's what we're calculating, the percent increase, times the original height. Well, the original height here was the 11 centimeters, so 9 equals R times 11. We're going to get R all by itself by dividing both sides by 11. So on the right, 11 divided by 11 is 1, leaving us with R. 9 divided by 11, if you punch that into your calculator, you get the decimal 81 hundredths repeated. The 8 and the 1 repeat. Okay, this is our decimal form for the rate. We need it as a percentage. And so this is going to become 81 and 81 hundredths repeated percent. Okay, again, move that decimal point 2 places to the right. And then there's an 8181 that repeats, so 81 and 81 hundredths repeated percent. And again, the question says round your answer to the nearest percent. So right now it looks like it's 81%. We check in the tenths place and see an 8, which is going to round us up to approximately 82%. Okay, and so we can say then there was about, because we rounded, there was about an 82% increase. There was about an 82% increase in the flower's height. In our last example, we're told that Morgan estimates that it will take 12.5 minutes to download a movie from an online movie store. It actually took 16 minutes to download the movie. Find the percent error in Morgan's estimate and then round your answer to the nearest tenth of a percent. So we're looking for a percent error in this example. So again, we're going to write our equation first. Error equals the percent times the actual amount. Okay, the amount of error equals the percentage of the actual amount. And so the first thing we're going to have to do is figure out how much error was there in Morgan's estimate. He thought it would take 12.5 minutes. It's really taken 16 minutes. So we're going to do a subtraction. 16 minus 12.5 is 3.5. All right, Morgan was off by 3.5 minutes. So that's the amount of error, 3.5. Equals, we're looking for the percent error, so R times the actual amount that it took to download the movie was 16 minutes. So that goes in for the actual. And again, we're trying to figure out what the value of R is going to be. So we're going to have to divide each side by 16. So we'll go ahead and do that. Divide each side by 16. All right, and when we do that, on the right, 16 divided by 16 is equal to 1, leaving us with the rate R. On the left side, 3.5 divided by 16, we punch that into our calculator, and we get the decimals 0 and 21875. And again, that's the decimal value for R, but we need it as a percentage. All right, so move that decimal point 2 places to the right. We get 21 and 875 thousandths percent. The question said to round your answer to the nearest tenth of a percent. So right now it looks like it's 21 and 8 tenths. We look at that hundredths place and see a 7, which is enough to round us up to approximately 21 and 9 tenths percent. And so that's what we can say. There is about a 21 and 9 tenths percent error in Morgan's estimate. There is about a 21 and 9 tenths percent error in Morgan's estimate.